Welcome to day 5 of the 100-day FPGA series. Today we will be completing Demultiplexer. In the last video we had completed multiplexer on FPGA, and today we will be doing the Demultiplexer part. So tomorrow, which is day 6, we will be doing our first small project in which we will be combining multiplexer and demultiplexer and our previous concepts like interfacing Arduino with FPGA. We will be using all those concepts to build a small project, a small communication project. So stay tuned for day 6 as well. For doing day 6 we need to master day 5, which is demultiplexer, right? So let's quickly get into demultiplexer. So let's first understand the working of a demultiplexer. In a demultiplexer you have one input port and 4 output ports and 2 selection lines. It is exact opposite of the multiplexer. Okay, so it basically takes one input line and it connects it to 4 output lines depending on what output line you have selected using these selection signals. Okay, so if the selection signal, let's draw the truth table. Okay, so our 2 signals, we have 4 combinations. We have 0 0 0 1 1 0 and 1 1, right? So for if we have selected the 0th one, if both the selection lines are 0, like 0 0, the input will be routed to the 0th output, like y0, right? So the y0 will have the input. Again, input can be anything, it can be 0, it can be 1, doesn't matter, it will be routed to y0. Just like in the multiplexer we had seen, the input was routed to the output. If the input is 0, it is 0, if the input is 1, it is 1, right? It's just routed to the output. So here also the input is routed to the output, and y0 will have the input, and rest of all these will be 0. Similarly, if I have 0 1 selected here, the input will be routed to this and will have y1 as the input, and rest all of them will be 0. Similarly here and here. So as you can see, it will be routed to the output like this. So now we will write the Verilog code for this. Okay, so the first method of implementing it in Verilog is again, whenever we have a truth table, that means we can derive a Boolean expression from it, right? So we have 4 output ports, we need to write Boolean expression for all 4 of them, right? So for y0th one, we need to have input routed to y0 only when we have either s1 equal to 0 and s0 equal to 0 as well, right? We need all these 3 conditions to be true, right? We need all these 2 conditions to be true, and input will just follow, right? So now I have written all the 4 output expressions for all the 4 outputs, right? In Verilog, again we will write all these 4 expressions and we'll see what kind of circuit we generate here. So let's go to Vivado and write the Verilog code. So I'll go to create project. So in here I will simply write all those expressions. So input ports, we have 3 input ports. You can see we have selection lines S1 and we have 3 input ports. As you can see, we have selection lines S1 and S0, and we have 1 input line, right? So I'll give S0, S1 and I as inputs, and output lines, we have 4 output lines, right? So we'll have y0, y1, y2 and y3, right? Now we will write the expressions for all of them. So I've written the code and written the expressions here. The next step of implementing a design on FPGA is writing the constraints file, right? So I'll add constraints here. Here we have constraints, and now we'll copy stuff that we require from the master constraints file. Here is my master constraints file. I need 3 inputs, so I'll take 3 slide switches, and what I'm going to do is replace it with names, right? I'll use the first 2 switches as the selection lines and the next switch as the input line. Okay, next I need 4 outputs, so I'll copy 4 switches. I'll copy 4 LEDs. So if you hold control while selecting, you will be able to select column wise, right? So just select column wise, and okay, you can just delete things, right? So I have defined all the inputs and all the outputs over here. Now we can generate the bit stream. Let's generate the bit stream. Okay, so I have generated the bit stream. Let's now put it on the FPGA and check the functionality. Okay, so I'll programmed device, go into hardware manager, open target, auto connect. And we'll program the device. Okay, I'll move on the camera to FPGA. Okay, so as you can see, the first 2 switches in the constraint file, we had set these 2 switches as the selection switches, right? S0 and S1, and the next switch is the input switch, right? So depending on what I select, I'll see the corresponding output take the value of the input. Okay, so right now the input is 0, so it doesn't matter whatever I select, that thing will be routed and you won't be able to see 0. So I'll keep the input to be 1, so that you can see which output is taking the corresponding value of the input. Okay, so right now 0 0 is selected, so the 0th output Y0 is being basically input is fed to the output Y0. Okay, and I will do 0 1. As you can see, the Y1th value is Y1th output is now connected to the input. Now I'll do 1 0. Now the Y21 is connected to the input, and now when I do 1 1, the Y3 is connected to the input. So this is how the demultiplexer works. Okay, we have implemented the demultiplexer on FPGA. So now we have implemented demultiplexer on the FPGA. So in day 6, I'm going to connect the multiplexer to demultiplexer, and we will have a communication setup over one wire, okay, in between 2 FPGAs. So that will be our first mini project in this series, okay, and we'll use the concepts that we have learned throughout the day 1 to day 5, okay. In day 6, we are going to do the project. So join me in, okay. Thank you for watching.